Hello to Legion Go and all the handheld gang out there. I'm back again trying to refresh things with even more handheld content. And believe me when I say, we've got plenty more to look forward to. But in this video, I'm diving into a pretty cool option inside the Legion Go BIOS called Core Count. Now what this does is basically let you choose whether you want to run the Z1 Extreme with all its 8 CPU cores or turn off some and make it down to 6 or even just 4. Just to clear it up right away, this option has nothing to do with the GPU 12 compute units, so don't worry, your iGPU performance isn't touched at all by this tweak. I've got to say though, it's impressive that Lenovo gives us this kind of a freedom in the BIOS without having to use any third-party tools. It's not something you always see on handheld devices. While it may not be that essential, but those kind of settings gives you more idea about how the device works under the hood and experiment with it. And actually, the only reason I decided to put the time and efforts into testing this was because one of you guys asked me to check this option out a while ago. So a big appreciation to our cool pro. You guys should know that I'll always try my best to fulfill your video ideas whenever possible, so never hesitate to ask. The BIOS version I'm using anyway for this video is the latest one as of this date, version N39. I've got the VRAM set to 4G, which is a solid choice because for gaming benchmarks, we'll be running them at a pretty low resolution. That way we don't end up bottlenecked by the GPU and can really see the CPU performance scaling difference more clearly. I've also left SMT enabled. For those who don't know, SMT allows each physical core to run 2 threads. So 8 cores become 16 threads, 6 become 12, and 4 becomes 8. That can help in some workloads, though not always for gaming. By default, it's on, so I'll be leaving it this way, but maybe in another video, I'll play around with SMT on and off at different core counts to see what kind of behavior we get. Now here is something important I need to point out. When you change the core count in BIOS, let's say you switch it to 6 cores and save, for some reason, the BIOS automatically resets your VRAM to 3G. It doesn't matter if you then switch it back to 8 cores. It still leaves VRAM at 3G when you change that setting. So it's not that the core count itself is tied to VRAM, it's more like the act of changing that setting just resets VRAM allocation somehow. So in case you change it, make sure you put back into BIOS afterwards and set VRAM again to 4G. This way everything sticks properly. For this whole test, I capped the TDP at 30 watts. That felt like the best comparison point because I don't want to be too power limited when checking CPU difference and to see if actually setting lower core count would reduce power consumption overall. And for resolution, I stuck to 800p. As I said, that helps us avoid GPU bottlenecking and makes it easier to see the actual impact of different CPU core count on performance. So let's start with Cinebench R23. The results were pretty interesting. On 4 cores, we scored 8,155 for multi-core, on 6 cores, 11,025, and on 8 cores, 13,538. So perhaps just like me, you might expect 8 cores to double the 4 cores score. Like if it was 8,000 on 4 cores, it should be around 16,000 on 8 cores. But in reality, we only got 13,000. That's just how these chips behave. Performance scaling isn't perfectly linear because there are shared resources, efficiency curves, and other limits at play. So the extra cores definitely help, but you don't get a clean 2x jump all the times. Looking at voltages, on 4 cores the CPU maxed at around 1.285 volts, on 6 cores it was 1.405, and on 8 cores it reached 1.465. And here is the funny part. The CPU actually ran hotter on 4 cores, hitting maximum of 86 degrees, while on 6 cores it was around 80. And on 8 cores, it was down to 78. That surprised me at first, but it makes sense when you think about it. With fewer cores, the workload is concentrated on each one, which increases per core power density and creates hotter hotspots. With more cores active, the work spreads out across them. So even though total power is higher, the heat is distributed better and temps can actually be a bit lower. I never knew of that prior to this. Then there is TDC, which stands for thermal design current. That's basically the sustained current the CPU can draw under load. It's measured in amps. On 4 cores, it was 24. On 6, it was 27. And on 8, it was 30. Then we have EDC, or electrical design current, which is a peak current the CPU can pull in short spikes. It's also measured in amps. On 4 cores, it hit 86. On 6 cores, it was 98. And on 8 cores, it went up to 105. That's exactly what you would expect. The more cores you've got available, the more current the chip can request at once. But in all cases, the chip's max power draw stayed the same, locked at 30 watts. That's because the CPU still has a fixed 30 watt power limit. With fewer cores, each one can boost higher while staying under that cap. And with more cores, the boost per core is lower, so the total still adds up to around 30 watts. Next test I did was 3D Mark times pi. While the final overall score didn't really change a lot, but the CPU scores definitely did. With 4 cores, it was 4,977. With 6 cores, it jumped to 6,892, and with 8 cores, we got 8,826. That's a pretty huge uplift just from having more cores active. The reason the overall score didn't move is because time spy weighting is heavily focused on the GPU. It makes up the majority of the final score. Since the GPU performance stayed the same in every run, the overall number barely shifted, even if the CPU subscore scaled up a lot. I also did still Nomad Lite, still in 3D Mark, which was on the other hand basically the same across all configs, since that benchmark is purely GPU bound and doesn't really touch the CPU. Something I noticed though, and this was a big deal, with 4 cores, the whole Legion Go just felt slower in day-to-day tasks. Windows felt less snappy, apps opened slower, and game loading times took way longer. For example, Horizon Zero Dawn loaded in about 14 seconds with both 6 and 8 cores active, but on 4 cores, 1 minute and 40 seconds. That's insane difference. I felt like the whole system experience takes a hit when you cut down to 4 cores. Then I moved to actual games benchmark. In Cyberpunk 2077, as you can see, CPU usage was at 100% on 4 cores. With 6 or 8, it drops down to 70 to 75%. But the FPS was surprisingly similar across all configs, because in that case, the iGPU was the real bottleneck, and having extra CPU cores didn't change much sadly. In Horizon Zero Dawn, CPU usage was high on 4 cores, but not as extreme as Cyberpunk. Between 6 and 8 cores, there was only about a 10% usage gap. FPS across all 3 configs was pretty much the same, both in average and loss. But Red Dead Redemption 2 told us a different story. On 4 cores, the CPU maxed out at 100% usage, and you could really see it struggling. With 6 and 8 cores, it was more balanced, smoother, and FPS was definitely higher, both in averages and lows. While Age of Mythology Retold, being a light RTS, isn't as demanding on the CPU, so usage wasn't too high even on 4 cores. But interestingly, the FPS difference was still big: 77 on 8 cores, 71 on 6, and only 54 on 4 cores. That's about a 25 FPS drop just by cutting down to 4 cores, which really shows how much it can hurt without you realize. And finally, in Counter-Strike 2, 6 and 8 cores both hit around 195 FPS, while 4 cores dropped a little lower at around 185. Not a massive hit, but still noticeable. So here is the takeaway. In CPU-heavy games, dropping down to 4 cores really tanks your performance, and it doesn't even save you any meaningful power, and you could even raise the CPU temperature. So there is basically no point in using 4 cores in my opinion. With 6 cores instead, it was honestly fine. It stayed pretty close to 8 cores, and that's because at a certain point, the GPU becomes the main bottleneck instead of the CPU. But the biggest thing for me was just how much slower the system felt overall when running on only 4 cores. Everything from loading times to Windows responsiveness just took a hit. I may do another video soon where I check performance with SMT on and off at different core counts to see what kind of impact that has as well. But in the meanwhile, I hope this video was useful for you guys, and I'd like to hear your thoughts in the comment. What do you think about the results? Did they line up with what you expected, or did anything catch you off guard? Let me know, and if you enjoyed the video, make sure to give it a like and subscribe to the channel. It really helps a lot. Also because I have more handheld content on the way, the Legion Go 2 and the ROG Xbox Ally X are right around the corner. And you can bet I'll be covering and stacking them up against the current gen handhelds. So you better stick around if you don't want to miss out. And finally, thank you a lot for watching and see you guys in the next one.